Hi, this is Harshit, a BTech CSE third year undergrad student from Bennett University. I'm interested and currently training in the fields of cloud computing and DevOps. As a part of our seminar subject, I have decided to present something on edge computing. Let's start by knowing about our university. Bennett University has been set up at Greater Noida and commenced operation on 8th August 2016, initially with BTech and MBA programs, and now provides courses in various fields including law, engineering, mass communication, management, and liberal arts, with a focus on giving students a premium learning experience in an immersive environment on its 68 acres campus. It is a research driven university with learning faculty from various prestigious institutes like IITs, NITs, and other foreign universities. It has various clubs and chapters for fun and learning. I was also a part of IEEE, Spark eCell, and Silhouette Art Club. It has state-of-the-art facilities for sports and recreation. It has an in-house incubation center called the Bennett Hatchery, which supports and help you to go further with your ideas and transform them to a full-fledged startup. Overall, it's a great experience to be at Bennett. Now, let's further proceed with my topic. Hi, the topic for my presentation is edge computing. Let's start by understanding what is edge computing. Edge computing basically refers to a distributed computing paradigm that brings computation and data storage closer to the source of data. It can be also understood as the framework of computing that stand close to the determinant roots of data. We can also say that edge computing is a type of computer program that delivers low latency nearer to the request, which in turn results in improved response time and saves bandwidth. Here we can see data being collected from the end user. The data will be further sent to these nodes where it will be processed and then further sent to the cloud. Before understanding the concept of edge computing, let's understand what cloud computing is and why is it needed. Cloud computing is a service that provides computing service on demand over the internet. Cloud computing backbone is the data center, the storage, and the computation of data. Multiple data centers are connected through an optical network to form a data center network or called DCN. Cloud computing has gained popularity among organizations due to its self-service capability, as there is no need to keep hardware and software maintenance staff. Its scalability feature, because it is easier for the organizations to expand, they can use infrastructure according to their requirements. In case of need to expand, they can request for infrastructure from the cloud provider. It's flexible, as the access to the cloud service is available over the internet. We can access it from anywhere. It's affordable, as it saves considerable amount of money for organizations, as they won't have to buy $1 million servers. Now, with Internet of Things being widely used, it has set up new requirements. Real-time processing of sensor data, the communication latency between end devices and DCN might prove to be bottleneck. As most of the IoT devices have agile nature, mobility support is necessary. Edge computing is an attempt which overcomes these shortfalls. It leverages the storage and computation capacity of large number of mobile, wearable devices or sensors. It acts as a layer between end devices and the cloud. As the edge devices handle requests locally rather than sending it to the clouds, this reduces the latency in solving the request and allow real-time handling of requests. Due to abundance availability of edge devices, it supports mobility. We can say that edge computing, also known as edge, help in bringing the processing close to the data store, thus eliminating the need to send data to remote cloud or server for processing. Let's understand the difference between cloud computing and edge computing. Cloud computing basically refers to the service that provides computing services on demand over the internet, while edge computing refers to the optimization of cloud to move the compute close to the source of data. Let's look at the characteristics of edge computing. It is geographically distributed. It is highly scalable. Edge computing is autonomous and distributed. It reduces the latency to a great extent. It does real-time interactions with data, and it increases the capacity. The application of edge computing includes applications that require autonomy. For example, autonomous vehicles. Or for autonomous driving vehicles to replace human drivers, cars must be capable of reacting to the road incidents in real time. On average, it may take 100 milliseconds for data transmission between vehicle sensors and backend cloud data centers. In terms of driving decisions, this delay can have significant impact on the reaction of self-driving cars. Industry 4.0 is also an example of applications that require autonomy. The manufacturing industry heavily relies on the performance and uptime of automated machines. Other applications include applications that can't tolerate latency, like applications related to healthcare or financial transaction, as they cannot tolerate any latency and the things need to be done in real time. Another application can be applications that require significant bandwidth. For example, smart surveillance system. As they generate huge amount of data within no time, it requires high bandwidth. Let's look at some of the features of edge computing. First comes privacy and security. The distributed nature of this paradigm introduces a shift in security scheme used in cloud computing. In edge computing, data may travel between different distributed nodes connected through the internet and thus requires special encryption mechanism independent of the cloud. Scalability in a distributed networks must face different issues. First, it must take into account the heterogeneity of the devices, having different performance and energy constraint, the highly dynamic conditions, and the reliability of the connection compared to most of the robust infrastructure of cloud data centers. Management of failovers is crucial in order to keep a service alive. If a single node fails and is unreachable, users should still be able to access a service without interruption. Moreover, edge computing system must provide actions to recover from a failure and alerting the user about the incident. Edge computing brings analytical computational resources close to the end users and therefore can increase the responsiveness and throughput of the application. A well-designed edge platform would significantly outperform a traditional cloud-based system. Due to the nearness of the analytical resources to the end users, sophisticated analytical tools and artificial intelligence tools can run on the edge of the system. This placement at the edge helps to increase operational efficiency and is responsible for many advantages for the system. Let's look at the advantages of edge computing. Edge computing provides faster response as it is operating at the source of data. Edge computing is secure because the data is locally stored, no theft during transport, and compliance is also maintained. Edge computing is highly cost effective as no need to transport everything to cloud. Edge computing is reliable because it can work without connectivity. Edge computing also has some of the disadvantages associated with it. Let's look at them. It is a complex process. Edge computing is open to environment, increases the risk and make it vulnerable for theft and piracy. The nodes are remotely located. Let's understand the relation between edge and content delivery network or CDN. Content delivery network is a network that supports caching of main server data to multiple CDN servers placed close to the end users, thus reducing latency. Before CDN was implemented, every request was sent to the main web server to be processed, in turn increased latency. CDNs have helped in achieving better quality of service and quality of experience to their customers. These CDN nodes placed close to the users with pre-fetched cached data reduces latency to a great extent, and video caching saves a lot bandwidth. Also, these nodes can help in building location-relevant advertising, thus helping advertisers to reach the audience. Over the years, CDN have increased in number and size. Over a third of internet traffic is being served by CDNs. it is expected to carry over half in near future. Edge computing extends the same concept by leveraging the cloud infrastructure. For both, the proximity to the end users is crucial. Bing is limited to caching wave, whereas cloudlets run arbitrary code just as in cloud computing. The similarities between CDN and Edge are both CDN and Edge computing are concepts built around bringing nodes close to the user edge. Both helps in reducing the latency to great extent. Both reduces load at the main server by distributing the traffic. In both concepts, the proximity of end users is crucial. The differences between Edge and CDN are: in CDN, just caching of content is done, whereas in Edge computing, cloudlets can run arbitrary code just as in cloud computing. So we can say that Edge computing is an extension to cloud computing. There might be a confusion between IoT and Edge as they look similar, but let's understand Edge computing is a topology and a location sensitive form of distributed computing, while IoT is a use case instantiation of edge computing. The terms refer to an architecture rather than a specific technology. Let's look at the future of edge computing. According to the Gartner Hype Cycle of 2017, edge computing is drawing closer to the peak of inflation expected and will likely to reach the plateau of productivity in 2 to 5 years. Considering the ongoing research and development in AI and 5G connectivities and the rising demand for smart industrial IoT applications, edge computing may reach maturity faster than expected.